Y'all good this morning?
Yes, ma'am.
Yes, ma'am.
Very good. Very good. Wait on everybody else to get logged in for a few minutes. All right, so I figured out the question. I sat down and looked at it, and I was trying to make that silly flag question so much more complicated than it was. As soon as everybody gets logged in, I'm going to tell y'all how blind I was and how I missed it. And I'm going to see if anybody else can figure it out before I tell y'all. It looks like Alec is joined to the Thursday meeting. Let me send him a message.
I actually just got here.
There you are. Awesome. Very good. That's what I just saw the email where it was, okay, so you got here in the right place. Awesome, awesome. All right. I think everybody's so used to me running behind. My computer just picked right up this morning when I turned it on. It didn't give me any trouble. I was surprised because with my son is home and he's Zooming and my husband's working from home, and so everybody's on the Wi-Fi, so I figured I'd have trouble, but so far so good. I guess I better knock on wood. All right, so while we're waiting on everybody, here comes Tyler. Looks like we are starting on page 490 is going to be where we're starting as far as content goes. I'll look and see there. So if you'll go ahead and start lining up your homework questions. Let's see, my flag question was from 8.2, so I will go over what I found with that and what I was missing completely. Have we gone over homework questions for 8.1 yet?
Yes, ma'am.
Okay, so we've checked 8.1. What about 8.2?
No, ma'am.
Okay, so I was thinking that was where we needed to start. That's where my flag question is, so I'll be able to tell y'all. I figured it out. All right, we got Keely coming in. One, two, three, four, five, six, seven, eight. Yep. Our homework. First, I will tell y'all, if we look at guided practice number 8 on page 468, hold on, I'll join up my screen. Excuse me. Let's see. Throwing it on number 8. So I have Googled and I have looked to see dimensions and all kinds of stuff. And I can't. It is so obvious. Or is that that's my little, I don't know, when did they do that? Like in my little, my arrow on Zoom, it was laying over your picture and it turned into a hand. So it looked like you had your hand raised. All right, so where am I going? I need my book. I need to go to Notability. And find my geometry book. And let's see, this screen over. All righty. Okay, so going back to 8.2, page 468, look at the flag, look at the problem. It says the blue portion of the United States flag is called the Union. What is the ratio of the height of the Union to the height of the flag? And so I kept looking back at number 7, thinking that the two were related, thinking that I was going to need to use that ratio that we had already been given, that, you know, we have the height, and then we found that the height was 6 feet, so the width was 11.4 feet. So I'm thinking that we've got to use all that information in this problem instead of just looking at the obvious. What is this? Okay. All right, now I'm really baffled. That's the craziest thing. So does y'all's book have the pink in there?
No, ma'am.
On
No, ma'am.
8.2? Huh?
No, ma'am.
Okay, so I don't know why, but for some reason, just this section of my digital upload has like all the answers. How about that? Okay, so first of all, look at the answer. It says that the answer is 7 to 13. Why? Where did they get 7 to 13? Stripes are on the flag. $13. What do the 13 stripes on the flag represent? Does anybody remember? I'll do a little history in our geometry class. What do the 13 stripes on the flag
Is it the
represent? Yes. The 13 colonies. So that's why we have 13 stripes, is for the 13 colonies. So the answer on here is 7 to 13 because if you count up the stripes on the flag and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many of them take up the blue? 7. 13. But anyway, and it's the craziest thing that for some reason my digital download is the download of the teacher's book, so that'll make it easier for checking homework. So let's go ahead and check our homework for 8.2. So in 8.2, our assignment was 468 through 470, numbers 9 through 27 odds, and then number 33. So we will start with 9 through 27 odds. And so first of all, let's look on page 468. Any questions on page 468? 469. All right, 469, we had numbers
Number 27.
23, 27, okay.
Yes, ma'am.
All righty. So let's take a look at this. And notice it says, given that LJ over JN is equal to MK over KP. So what I'm going to do is I'm going to go ahead and look at these measures. And so what is the measure of LJ? Can I figure out LJ?
Not yet, no, ma'am.
Not yet, okay. And so it says find the measure of JN. So what is the measure of MK? That's going to be 12. And then KP is 9. So we do know 12 over 9. What does 12 and 9 divisible by? 3. So that's going to give me 4 over 3. So I know my ratio is 4 to 3. Okay. So what is my total side of let's see, what is my total side of MP?
21.
12 and 9 is 21, right? So looking at the sides that I have, that it says LJ and MK. So what I'm going to do is, remember, I can compare these two. So I do not know what LJ is, but when I put that in, I'm going to let that be X over my total side of 16 equals 12 over my total side of 21. You good with that? So I'm going to
Yes,
have
ma'am.
21x is equal to, and then let's see, 16 times 21 is 336. Divide by 21, divide by 21, and 336 divided by, hold up, what did I do? Yeah. Divided by 21 is 16. Okay, so I can see that, no, that's not right. Hold up. I started with the wrong part of the problem. Let me erase real quick. We know that LJ to JN is equal to MK to KP. So we just said that, yeah, so we're just going to use that. We've got that 4 to 3 is equal to, why am I 4/3 of 16? Hold on. Whoop, go back. Good grief. Just a second. 4 times 16. That's 16. So 12 over 21, because that's M to K, equals X over 16. Isn't that what I just did? So 21X is equal to 12 times 16. Oh, I think I must have multiplied wrong. I think I did 21
It's
times 16 when I
192.
did it the first time. That's why I was so confused. Okay, so 12 times 16 is 192. Divide by 21. Divide by 21. Divide by 21. And that's 9.14, but I'm going to look at it as a 192, 9, 18, 12. That's going to give me 3. So, okay, yeah, let me, sorry, when the first time I did it, I calculated wrong. I did 21 times 16 instead of 12. So what we've got is we just said that we're comparing, I have to look at this section here compared to this section here and the whole to the whole. Okay, so I'm looking at x over 16 is equal to 12 over 21. So I'm looking at my portion to the whole compared to the portion to the whole of the next one. Okay, so when I multiply, I've got 21x is equal to 192. If I divide by 21, divide by 21, 21 will go into 192 9 times. That's going to be 18. I'm going to subtract 12, 8. So that ends up being 3. So I have 9 and 3 over 21, which reduces to 9 and 1/7. Okay. So if I have 9 and 1/7, I'm going to have 16 minus 6 and 6 over 7. Okay. So if you would have done it though as a fraction, you could have reduced it. So basically 9 and 1/7, that's not what I wanted. 9 and 1/7 is roughly 9.14. So you could have taken 16 and subtracted 9.14. And so 16 minus 9.14 would be 6.86. So as a decimal, you could have 6.86, or as the fraction, you could have 6 6/7. So remember, when you're setting up a proportion, you just want to make sure that you're setting up consistently. So I would have side to whole length, and then cross multiply. So we found that section and then subtracted from 16. For other parts that we could have compared, probably would have been the easier route instead of having to subtract. We could have also said that we're looking for JN. So I've got this side to the whole length compared to this side to the whole length. So again, I could have had x over 16 is equal to 9 over 21. Still end up with 21x is equal to, and then 9 times 16 is 144. And then I could divide by 21, and I end up, if I have it as a simplified fraction, that's going to be 6 6/7, or approximately 6.86. Okay, so you could have set it up either way. Find this portion, then you would have to subtract from the whole, or you could just set it up the easier way and just compare these two sides, since that's what we're solving for. But either way, you'll end up with the same answer. Okay, other questions on this page?
I have questions on the mixed review, 51, 53.
Okay, so let's go ahead and take a look at page 471. Mixed review. Okay, so let's take a look at, you said 51 and 53?
Yes,
All right,
ma'am.
so take a look at 51. What kind of figure is this?
Isosceles triangle.
Not a triangle,
Oh, quadrilateral.
it's a trapezoid. No, it's an isosceles trapezoid. So what did we learn about the properties of an isosceles trapezoid? What do I know about these right here? We said with an isosceles trapezoid, we have two pairs of congruent base angles, right? So I know that my bottom base angles are, know that at the top, that's going to be 115. So that means this one's going to be 115. Okay. What do I know the sum of my 4 angles will be? 360 degrees, there's a quadrilateral. So if I add 115 and 115, I've got 230. So I'm going to say 360 minus 230. And that ends up leaving me with 130 degrees. So I know that that 130 has to be divided by 2 to get divided by 2 is going to be 65 degrees. Okay, so remembering those properties of an isosceles trapezoid that has 2 pairs of base angles that are congruent. So if my top one is 115, my other top one's 115, and the bottom 2 are 65. Let's look at 53. Same thing here. Isosceles trapezoid. If this one's 80, then this one's 80. So I know that 360 minus 160 degrees, that's the 80 and 80 is 200, and this one's 100. Anything else on the mixed review?
Miss Jennifer.
You do the same thing? Uh-huh.
Just for you know, Claire Jane's about to log in.
Oh, I'm already in.
Okay, she's here.
Yeah. I had some
She's
trouble
here.
getting in. It's all right.
Sorry.
That's fine. Sorry about that.
That's good.
Thank you, Garrett.
I have a
Okay,
question.
and then
though.
55, same thing. You've
Yes,
got one angle that's 41, so the other one's 41. Add them together, subtract from 360, and you find that each of the other angles, C and D, are both 139. Any other questions on 8.2 homework?
I have a question, but it's not related to the homework. Why do we keep on changing the
What's
code
that?
for this class?
We
Okay.
don't. Today is Wednesday.
Oh. It's just
So
as if
we
gone
have
through
one
so many
code for
codes.
Wednesdays and one for Thursdays. Yeah, we have one for Wednesdays and one for Thursdays. And so the main thing is just checking to make sure whether you're on the Wednesday code or the app. And immediately I looked down and I was like, oh, that's Thursday. Today is Wednesday. So just remembering what day of the week of it. That's the hardest part, I think, is when we're home, is remembering what day of the week it is.
I think I was
anyway.
on an old Zoom link from a long time ago where it said Wednesday, but I
Me
know it was
too.
on a Wednesday link. It was weird.
Okay, and sorry, I'm just now seeing your email because I just looked at that, and
That's all right. I was just wondering how to get in.
okay, I think I set up a new one and let me go ahead and look that up real quick, and I'll send y'all because I need to send it to April. Let's see. Go to Zoom on my phone and pull up the link for today. Schedule. Nope, that's not what I want. Cancel. I need my meetings.
Miss
Meetings.
Jennifer, I'll be right back.
So, okay. Zoom on Wednesday. Invite. April. Okay, so what I'll do is I'm going to set up, I'm going to send you guys an email right now that has, let's see, Geometry Wednesday, invite, copy to the clipboard. And I'm going to go to Gmail and start a new email. Here she comes. Hey, April, I'm so sorry. I just looked down at my phone and saw where you were trying to get in. And what I'm going to do right now is I'm going to go ahead and send an email to everybody that has both of the links in one email. So you only have to go that one. set this up real quick. I have to go to my groups. There's geometry, and I'm going to send an email, and I want all of these contacts, Gmail. All right. Geometry, Zoom, links. Okay, here is the link for Wednesdays. Paste. Okay, so let's see. We really don't need all of this mess. So what I'm going to do is I'm going to delete some of it where it's just the link. Y'all don't need to know that all the dates that it goes through. Hey, April.
Yes, ma'am.
Are you still there, April?
Yes,
Can you
ma'am.
hear me? Okay. I think you were just frozen a little bit. I just wanted to make sure you were in. I think your mama had just texted me that you were still trying. Let's see. So we can delete all of that too. Okay. So there's Wednesdays, and then below it, I'm going to make a big chunk of space. And let me go to Zoom and pull the link for Thursdays. Invite, copy to clipboard. Go
Miss
back to
Jennifer,
my message.
do you want us to send in the homework, or are we gonna bring it to you in person whenever we're in person next?
So I'm going to set up, so with the homework, what we're going to do is you'll just hang on to everything and we're going to submit it all at one time with chapter 8. And so I will, at that point, I will put a link for you to load it all up. So for now, just keep it all organized and all of it will be turned in at one time with your note packet and your test. And so, so just go ahead and start keeping it stacked together all in one bit in order. Okay, let's see. So here's the Thursday. So we'll get that set up. Delete the rest of this extra stuff. Ah, man, I did the wrong thing. Hold on a minute. Let me do it again. Deleted too much. Does it usually ask y'all for a meeting ID or passcode? Do y'all need that information, or is it just the link y'all
No, it
click?
just puts me straight into it.
I need the passcode.
Okay, that's what I was thinking. So,
Whenever you put the link, I just
alrighty.
click on that and it puts me automatically into it.
Okay. That's what I was thinking. I didn't think we ever had to really have the passcode because I had accidentally deleted that in one and I was trying to decide if I needed to take the time to go back and find it. I'm just trying to where it tells you that it's going to occur 14 times over the next whatever. Y'all don't need all those dates. You just need the link. I'm trying to make the email as short as possible. Okay, this is geometry Thursdays. All right, so I have just sent both of the links in one email. If there's anybody that wants me to send it to a different email address, I think I've got a specific one for most everybody. So anyway, if y'all don't get it, let me know. But I just sent one that has the links for both classes in one email. So all you'll have to do is like search your email for Geometry Zoom. And it's going to be, that one email will be for both days. Okay. All right. So we have checked 8.2. For those of you that were not around for my revelation of the flag problem, it's because it has 13 stripes and 7 of the 13 stripes are the part that is the union. So that's what happened with that. All right, so let's move on to 8.3 homework. And I don't know why just that 8.2 was the page from the teacher book. Nothing else has the answers in it. That's crazy. Okay, so 8.3. We had pages 476 to 477, numbers 9 through 41 odd. So let's go ahead and start on page 476. Any questions from page 476? All righty. What about 477? Any questions on 477?
29 and 41.
29 and 41. Okay. Clara, were you going to say something?
Yes, I have 21 and 23.
Okay, so 21 and 23, and then 29 and 41, Alec?
Yes, ma'am.
Okay, any other questions on this section? Okay,
On 21.
uh-huh. Okay, so we're going to be doing 21 and 23 on page 476. So let's go ahead and take a look at, they've told us we have similar polygons that we're using. Remember when I have PQRS is similar to JKLM, I know that P and J correspond, Q and K, R and L, and S and M, okay? So I've got to find the values of W, X, and Y. So when I'm finding, first of all, we'll find the value of W, okay? So if W is side QP, what does QP correspond with? If side QP is right here, what side does it correspond with?
KJ.
It's going to be KJ, right? So that means I've got W over 25. So now what I've got to do is I've got to set this up. And since I put W first, then I've got to go back to this figure and I've got to find a side that has a measure that corresponds with the other side of a, and so I can see that the two sides I'm going to focus on for this problem are going to be QR and KL because they both have measures given. So when I set up my proportion, I'm going to have 12 in the numerator, 15 in the denominator. So because I have W in my first denominator and I started with the smaller figure, then I go ahead and say W over 25 is equal to 12 over 15. Are you good with how we set that up? So now I can cross multiply and I have 15W is equal to 12 times 25. And then grab my calculator real quick, 12 times 25. 12 times 25 is 300. So I divide by 15, divide by 15, and W is equal to 20. 20, yeah, 20. Okay, you good with that? So now I know that this is going to be the standard. This is going to be the side that I'm going to have to use, or this is going to have to be the ratio that I use to solve for the other ones as well. So now when I set up for x over, okay, I know that x is LM. So what side corresponds with LM? It's going to be RS, right? So I have x over 10 is equal to, and again, I'm using 12 over 15. Cross multiply, I've got 15x is equal to 120. Divide by 15. Divide by 15. And x is equal to, what happened? X. Oh, I flip-flopped them. Y'all didn't catch my mistake. This one now, since I did this figure first, then that means the 15 needs to be in the numerator. So I need to have 15 over 12. Is everybody good with why I had to flip-flop that? And the first one I did W as my first variable. And so since I started and I went this figure and compared it, and my denominator was this figure, now this is my numerator, so this has to be my denominator. All right, so let's fix that. So 12x is equal to 150 divided by 12, and 150 divided by 12 is 12 and a half. Okay, so now I'm going to pay better attention as I'm setting this next one up. And so my next one, y. All right, so remember, if I have y over, the corresponding side is 16. Again, I've got to do 15 in my numerator because it's on the same figure as y over 12. So 12y is equal to, and 15 times 16 is 240. Divide by 12, divide by 12. So y is equal to 20. So x is 12 and a half. W is 20, x is 12 and a half, y is 20. So the main thing is, remember, when I set up a proportion with an unknown value, I know that I've got to have two ratios. So I just have to make sure when I set up those two ratios that I have my corresponding information in the numerators and denominators. So that was where I messed up setting up the second one. All right, so that was 21. 23 says find the ratio of the perimeters, the perimeter of PQRS to the perimeter of JKLM. So in this one, now that I know my side measures, I'll change my color real quick and we'll plug in these side measures. We said that X was 12 and a half and Y was 20. And we said that W is 20. So now when I set up the perimeter of my first figure, so my perimeter, remember to find perimeter, that means I add side plus side plus side plus side. So I have 15 plus 12.5 plus 20 plus 25. So I'm going to add all that up, 15 plus 12.5 plus 20 plus 25. So that's going to be 72.5. Now I need to find the perimeter of this one over here. Let me erase all this so I have some room. Okay, so I got the perimeter over here. P equals 12 plus 10 plus 16 plus 20. So let's see, 12 and 10 is 22, plus 16 is 38, plus 20 is 58. So now it says the ratio of the perimeters, okay? So when I set these up, and it says the perimeter of PQRS to JKLM. So they are telling me the order that I need to set these up. So because they said PQRS first, that's what goes in my numerator. So this is the perimeter of PQRS. So that is 50. Oh, no, wrong button. Sorry. Come on. There we go. Now I just need that mark to go away. I'll just use my eraser instead of the back button. Okay, so that is going to be 58 over 72.5. Okay, so again, I have to make sure that I can reduce. Okay, so let's see. All right, so what I'm going to start with, let's see, 13, 14. All right, this one's not an easy one to reduce, but basically they are both divisible by 14.5, okay? So divided by 14.5 divided by 14.5 equals 4/5 reduced, okay? So basically if you started kind of trying to reduce, basically you could see that it's going to be between 14 and 15 would be what they're both divisible by. So in this situation, I would not count off for reducing because that's a difficult one to have to simplify. If so, find the scale factor. All right, so again, I have an isosceles trapezoid. We've had a lot of these recently. So we have an isosceles trapezoid here. And when I look at it, what do I know? Let's see. I always have to be very careful because I always want to apply the theorems and the things that I already know to this, but based on what it has marked, okay? So, and also thinking about, okay, so looking at what they've marked, I can see that I've got, that over that. Decide if they are similar. So let's take a look at that. If I were to set up my proportions and I have 8 over 18 is equal to 14 over 18. I can look at that immediately and see, is that going to be proportional? If I multiply 14 times 18 and 8 times 18, are those going to equal the same number? They're going to equal different numbers. So just so you can see it, if I do 8 times 18, that's 144, and 14 times 18 is 252. And that does not equal 144. So because this side over this side is not proportional to this side over this side, they are not proportional figures. Okay, so all I have to do is plug in. I could have also said 18 over 30 is equal to 14 over 18. I could have done 18 over 30 is equal to 8 over 18. I could compare any of the two and set them equal to two other ones and look to see if they were proportional, and they are not. Okay. Any questions about that? All right, and then last one, number 41. Okay, so it says the two polygons are similar, so find the values of X and Y. So let's take a look at this. what side is going to correspond with x minus 6? $39. Okay. So what I'm going to do is I've got to set this up on the values of x and y. So I've got x minus 6 over 39 equals, and then I'm going to compare 18 over 21. So I'm going to set this up and come down here where I have some workspace. So I'm going to have 21 times x minus 6 is equal to 39 times 18. So it's going to give me 21x, and then 21 times 6 is 126, so minus 126 is equal to 39 times 18 is 702. Add 126, add 126. 21x is equal to 702 plus 126, 828, divide by 21, divide by 21. And that gives me 39. As a fraction, it's going to give me 30, and as a decimal, it'll give me 39.4. If I wanted to leave it, so that's going to be approximately 39.4. If I want to do as a reduced, as a mixed number, that would be 39. So 21 times 39 is 819. And 819 and 828. Oh, that's wrong. Hold on, clear this. 828 minus 819 gives me 9 over 21, which reduces again, and that would be 39 3/7. Okay, so I could have it as a fraction or a decimal, but look at that. And because I'm doing proportions, immediately, I think probably what you're looking at is you would go, hey, x minus 6 equals 39, add 6 to each side. So, but that's not the way it works. We're not finding lengths of sides, we're finding proportions. Okay, so then for the next one, I'm having to compare y, and y over 27. So y over 27, that's the 21, equals, now again, I take my two sides that I know for sure, 18 over 21. So I have 21y is equal to, and 18 times 27 is 486. Divide by 21, divide by 21. So 486 divided by 21, again, gives me a decimal if I use a calculator. So that's going to be approximately 23.1 or 23.14 if you want to go that far. But as a mixed number, it's going to be 23. So 23 times 21 is 483. So that's 23 3 over 21, which is going to reduce to 23 1 over 7. So as a fraction, you're 23 1 over 7. As a decimal, you're 23.1. Any questions on how we did that? Because I'm finding proportions, I have to look at my sides that are proportional. I have to set up what I know, what my known two sides are to a side that has a variable. Any questions on that? All righty. let's go ahead and take a look at 8-4 similar triangles, pages 483 to
Miss Jennifer.
485. Huh?
What time is our break?
I'm sorry.
What time is our break?
It was 2 minutes ago. So why don't we go ahead and take a break, and then we'll come back and we will look at 8-4 homework. Okay? Or did we finish 8-4? Yes, we did. So 8-4, we'll check when we get back. 5 minutes.
Hey, Miss Jennifer, I
Mhm.
emailed you 5 and 6 tests. I don't know if you got them yet.
Did. I have got them. Thank you, thank you, thank
And then I
you.
need to email, I think, the rest of chapter 6 work.
Okay, perfect, perfect, perfect. And if there's anything as you're going through that you need help on, if you're, catching up and stuff, anything that you need, be sure to let me know, okay?
I
All
was
right.
sick all week last week.
I know,
so,
bless your heart. You feeling better?
I'm getting there, but yes.
Getting there. Yeah, it's day at a time, day at a time. Well, like I said, if you need any help catching up, be sure to let me know, okay?
Okay.
Okay. All righty. So we'll get ready and come back. So our previous section was dealing with similar polygons. Okay. Now we're specifically talking about similar triangles. And in this section, we started bringing back a little of what we've already previously talked about with triangles. And so let's go ahead and take a look. So our first part of our homework was page 483. We had 9 through 17 odds. So let's go ahead and start there. Page 483, 9 through 17 odds. Any questions here? All righty, let's go ahead and turn the page to page 484. And on 484, we started with number 18 and went 18 through 31 odds. Any questions here?
29 and 31, please.
Okay, 29 and 31.
Number 27.
27. Any other questions? All right. Of course, as soon as I get ready to start, the dog wants to come back in. Hang on just a minute. All righty. Okay, so it says for number 27, using the labeled points, find the slope of the line. To verify your answer, choose another pair of points and find the slope using the new points. So remember, slope of the line. What is our formula? M equals y2 minus y1 over x2 minus x1. So basically it says use 2 points to find the slope and then use 2 other points to check it, okay? So it does not matter which 2 I start with. I can pick any 2 on my line. So I'm gonna go ahead and start with my outside 2, okay? So I'm gonna say, and remember if it helps you, if you wanna say, okay, I've got x1, y1, and this is x2, y2. So I will have -3 minus 3 over 7 minus a -8. So -3 minus 3 is going to be -6 over 7 minus a -8 is going to be 7 plus 8, which is 15. That's going to reduce. They're both divisible by 3. So I ended up divide by 3, and I've got -2 over 5. Okay, so there's my slope for those 2 points. Now I'll use these 2 points in the middle. And again, I could use any other 2 points. It doesn't really matter. So I'm going to go ahead and say, all right, I've got x1, y1, x2, y2. So I've got -1 minus 1 over 2 minus a -3. 1 minus 1 is -2. 2 minus a -3 is 2 plus 3. So that's -2 over 5. These 2 are the same. So I have used 2 sets of points to confirm my slope, and the slope of this line is -2/5. Any questions on that one?
Miss Jennifer, wouldn't it be -26 because you would? No, never mind.
Yeah, it's 2 minus a -3. Okay, it's not multiplying. Okay. All right, so now on 29 and 31, we've got our figures, and it says find coordinates for point E, so that triangle OBC. So let's go ahead and take a look at that. We're talking about OBC. We're talking about this triangle here is similar to triangle ODE. So what I'll do is, well, I'll highlight. And so then ODE is going to be this big one. Okay, so it says that I can see that point O is 0, 0. B is 0, 3. Whoop. So I'm gonna go ahead and use, this is 0, 3. D is 0, 5. C is 6, 0, 0, 0, 0, 3, 6, 0, and 0, 5. So I'm trying to find what is point E. Okay. So think about what is my proportion? How do I want to say this? So 3. So basically, if I'm looking at, let me make sure I'm doing this right. 3 over 5 is equal to 6 over X. Yeah, okay. So basically what I'm doing is I'm setting up this proportion to where I'm saying I'm comparing, from my origin 0, 0 to 0, 3. That's going to be 3 units up, right? So I went 3 units up here. And then the total distance to go up to 5 is 5 units. So I have 3 units over 5 units equals, to go this way, I go 6 units, but I need to figure out what this needs to be. So that's going to be X. So I set up 3 over 5 is equal to 6 over X. So now I've got 3X is equal to 30. Divide by 3, divide by 3. So X equals 10. So this ordered pair would be 10, 0. Is everybody good with how I did that? I looked at my distance from my origin for my 0.03, and that was 3 places from the origin. For my ordered pair 0, 5, it was 5 places for the origin. So I set up a proportion where I had 3 over 5. I could have set it up where I had 5 over 3. I could have put 3 over 6 over here and done the same thing, as long as I'm consistent. So like I said, I could have had 3 over 6 is equal to 5 over X. Still going to be the same thing. I'm still going to end up with 3X equals 30 and X equals 10. Okay. The main thing is that I'm consistent with how I set everything up. So then we have number 31. So let me erase the, does anybody need me to leave that? Are we good to move on to 31? Okay. So 31, let me erase all this. Okay. So in 31, again, we've got the origin, which is 0, 0. B is going to be 0, 1. C is 5, 0. D is 0, 6. So I'm going to do the same thing here. Okay. My distance from 0 to 1 is 1. My distance from 0 to 6 is 6. So 1 over 6 is equal to, this side, I've got a distance of 5, and I've got to figure out what the distance is here. So that's going to be X. So X equals 30. Again, if I wanted to set up this side compared to this side, I'd have 1 over 5 equals this side compared to this side, 6 over X. Still X equals 30. So it doesn't matter which pairs you decide to compare, as long as you're consistent and making sure that the corresponding numbers are in the numerator and denominator. Any other questions on this page? Now let's look at 485. 485, we went through number 41 odds. Is that all we did? No, 47 odds. Okay. So any questions on page 485? Is everybody getting pretty comfortable with setting up your proportions? Remember, sometimes it literally takes tracing with your finger to make sure, or to highlight or to color or circle, just like I've been doing. So like if I'm looking at this problem here, I can see that P compares to 7. and 8 compares to 16. So just making sure that I'm, or I could, so like I said, in this one, I could have P over 7 is equal to 16 over 8, because this was first, this was second. Therefore, this has to be numerator, this has to be denominator. Or I could set it up differently, and I could say, well, I'd rather compare P to 16 and 7 to 8. P over 16 equals 7 over 8. I'm still going to end up with my same thing. P times 8 and 7 times 16. P times 8, 7 times 16. When I cross multiply, I'm still going to end up with the same thing. So I just have to be consistent. Okay. So any questions on this page? All right. 487, 61 through 71 odds on our mixed review. Any questions on the mixed review? All right, y'all are rocking on this section. All right, we started 8.5 and we stopped on page 490. So let's go ahead. Remember, we had previously in 8.4, we had looked at using angle-angle similarity postulate, where we said if we have two angles of one triangle that are congruent to two angles of another triangle, then the two triangles are similar. 8.5, we picked up with looking at side similarity. So if three sides of one triangle are similar to three sides of another, then they are similar. And then side angle side, if I have a side, an angle, and a side of one triangle that are congruent to the side, angle, and side of another, again, they are similar. So let's go ahead and, what did I say? We stopped on page 490. All right, so we were starting with example 4, and they were talking about using a pantograph. And so basically when we talk about scale drawings, and you can see how basically they've set up a bunch of angles to be able to look and say, okay, if this is my original drawing and I'm trying to enlarge it, how can I compare my measurements? So it says, as you move the tracing pen of a pantograph along a figure, the pencil attached to the far end draws an enlargement. As the pantograph expands and contracts, the three brads and the tracing pen always form the vertices of a parallelogram. The ratio of PR to PT is always equal to the ratio of PQ to PS. Also, the suction cup, the tracing pen, and the pencils remain collinear. Okay, so there's a whole apparatus here looking at being able to keep everything proportional when you're trying to enlarge a drawing. So let's go ahead and take a look. And so it said that the ratio of PR to PT. So what I'm going to do is I'm going to highlight. So the ratio, let me change my color real quick. Let's make it purple. Maybe it'll stand out. So they said the ratio of PR to PT. Make it green. I guess that doesn't help too much. So PR to PE is always equal to the ratio of PQ to PS. So again, PS, and then we've got PQ. Okay, so we can see our corresponding sides based on the colors, the two purples and then the green. So it says, how can you show that PQR, triangle PQR, QR, and PTS? So basically, I've got a small triangle here, and we're comparing it to the big triangle. So if we look at the solution, it says you see that PR over PT is equal to PQ over PS. And because angle P is congruent to angle P, we've got side angle side. Okay, so I know that right here, either triangle that it's involved in, whether it's the big triangle or the smaller one, angle P is still the same measure. So I've got side, angle, side congruence. Okay. In the diagram, PR is 10 inches and RT is 10 inches. So let me erase real quick and we're going to diagram that. So we said PR, is that what they said, is 10. And RT is 10. The length of the cat RQ in the original print is 2.4 inches. So we are trying to find TS. So if I'm trying to find TS, and we just said that the length of the cat is 2.4. So I know that that length, and I'm trying to find this one over here. So again, I can set it up to where I've got the total length of this side is going to be 20. So if I compare PR to PT, so that's going to be 10 over 20 over 2.4 over X, solve, and we get 4.8. So again, I'm just using my two sides of my triangle. I'm setting it up. Uh-oh, I lost Easton. Where'd he go? He's gone again. Okay. So again, I'm just looking at my picture. I'm able to compare my the two ratios that I'm setting up and use a variable for the proportion or for my unknown side. And then on page 491, using distance indirectly. Rock climbing, you're in an indoor climbing wall. To estimate the height of the wall, you place a mirror on the floor 85 feet from the base of the wall. I guess when you go rock climbing, you can take your own mirror so you can make measurements. And it says, then you walk backward to see the top of the wall centered in the mirror. You are 6.5 feet from the mirror and your eyes are 5 feet above the ground. So basically, here's our mirror, okay? Or that's where we can see the center of the wall or the top of the wall in the center of the mirror. So you are 6 feet from it and your eyes are 5 feet from the height, from the ground. So therefore, I can set up my proportion to where I am looking at, if this is what I'm trying to find, I know that DE is to BA, so X over 5 is equal to 85 over 6.5. Cross multiply, and you can see that we have an approximate number of 65.38. Okay, so again, I'm just making sure that I'm consistent in setting up my proportions.
Sorry, it said my Zoom had an update, so I had to kick me
That's
out.
fine. That's fine. All right, and then finally, example 6, finding distance indirectly. Indirect measurement to measure the width of a river. You can use a surveying technique shown in the diagram. Use the given lengths measured in feet to find RQ. Okay, so if we're looking at our little figure here, I can see that PQ is 63. I'm trying to find this right here. So that's my variable X. All right. So what measure corresponds with PQ? What measures with 63? 9, right? So I can set it up to where I have got 63 over 9 equals X over, and I can see that 12 corresponds with X. So 9X is equal to, well, 63 times 12. Let's see. 63 times 12 is 756. Divide by 9, divide by 9. And that gives me 84. Okay, so I can just see that the main thing is I'm just setting up proportions like I've been doing. I just have to make sure I've got my corresponding sides. I think I've said that 950 times now. Corresponding sides, corresponding sides. All right, so let's look at our practice. You want to prove that triangle FHG is similar to triangle RXS by the side-side-side similarity theorem. Complete the proportion that is needed to use this theorem. So here we say FH is 2. So remember, if I'm comparing FH, this will be RX is 2. Now on this one, I've got XS, so my numerator is going to have to be HG. And then FG to RS. So again, using figures, using the naming, look to see what is corresponding. All right, the next section says name a postulate or theorem that can be used to prove that the triangles are similar, and then write a similarity statement. So let's take a look at this. All right, so I have 2 triangles here. So think about, first of all, let's think about the ones that we can use. We know we've talked about angle, angle. We looked at angle, side, angle in this section. So the, I don't know, we did not do angle, side, angle. I did side, angle, side. So 8-4 was angle, angle. 8-5 we had side, 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 and side, angle, side. Okay, so these are my 3 options here. So I'm looking at these 2 figures and I'm saying, can I use angle, angle, side, 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 angle, side? Well, I can see they have not given me any marks of incongruence for sides. So I know my only option is going to be angle, angle, and it is telling me that actually all 3 are congruent. Therefore, I can use angle, angle, congruence, okay, or angle, angle, similarity. So now I've got to look and do a similarity statement. So if I start with,
Would it be triangle ACB is similar to triangle DFE?
Okay, so let's take a look at it. If I started with ABC and I went A, then it is going to be similar to what angle is A similar to?
D, and then
D, and
F
then
and
B is similar to E, and then C is similar to F. Okay, so we're just making sure that A and D are similar, B and E, C and F.
So could you do like a different sequence of like, could you like ACB and then just make sure that you could make it equal to the other triangle?
Yeah, if you wanted it to be triangle ACB, and that would be similar if you said A, then C, then B, then you would have to say triangle DFE. So again, as long as you make sure that you're in the same order, you can do that. All right, let's look at number 3. Notice I have a measurement for a side, I have a measurement for an angle, and I have a measurement for a side, and an angle, and a side. So this will be side, angle, side, similarity. And so that means when I look at triangle ABC, I know that A corresponds with D. B is going to correspond with F. And then C corresponds with E. Any questions on that one? All righty. Number 4, which triangles are similar to triangle ABC, and explain. All right, so I'm starting with ABC. And then how can I determine similarity? What do they have to be? What do we know about them? What do I know about side AB? if I have AB is congruent to JK, right? So that means I would have 4 over 2.5. I could reduce, and that would be what? I guess we can just leave it as that. We wouldn't have to reduce. Then I can have BC over KL, and that would be 6 over 3.75. And then I can have AC over JL, and that would be 8 over 5. So basically, I've got to look and see, are all these proportional? And the way that I can check that is I can say, okay, 4 over 2.5 equals 6 over 3.75. Cross multiply. 4 times 3.75. 4 times 3.75 is 15. And 2.5 times 6 is 15. So those are proportional. Again, I could check these two sides and have 6 over 3.75 is equal to 8 over 5. I know 6 times 5 is 30. So 8 times 3.75 is 30. So I've got proportional sides there. So I know that this one is proportional to it. I would go through the same measures and set up AB to MN, BC to NP, AC to MP, check to make sure they cross multiply to equal the same thing, and those are proportional as well. Okay, any questions on that?
So are both triangles proportional?
Both of them are.
Okay.
Mhm. For the sake of time, we're just going to keep on moving though. All right, so number 5, the side lengths of triangle ABC are 2, 5, and 6. Okay, so they just told us 2, 5, and 6. DEF has lengths 12, 30, and 36. Find the ratios of the lengths of the corresponding sides of ABC to DEF, and are the two triangles similar? So basically in this situation, if I've got 2, 5, and 6, that means 2 corresponds with 12, 5 corresponds with 30, 6 corresponds with 36. Okay, 2 over 12 reduces to 1 over 6. 5 over 30 reduces to 1 over 6. 6 over 36 reduces to 1 over 36. So because all of those proportions, they're the same ratio, then I have got similar triangles. And because we were comparing 3 sides of one to 3 sides of another, what postulate am I using here? Or which similarity theorem is it? Angle, angle, side, 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 or side, angle, side? What did I compare here? It says the side lengths are 2, 5, and 6. So that's side, side, side. We compared it to the side, side, side of the other one. So this is going to be side, side, side. Okay. So that's what you're going to be doing in this first section down here in the practice. So 6 through 8, this section says in exercises 6 through 8, determine which 2 of the 3 given triangles are similar. You're going to need to set up proportions for each of the sides. As long as the ratios are the same, then they are similar. Okay, and so actually on this one, we just have number 7. So you're going to need to do just like we did in activities or in practice 4, where we set up proportion statements for each of them and said AB to JK, BC to KL, AC to JL. And then you've got to compare this first triangle to the second one as well, doing the same thing. Okay, so that's what you'll be doing in number 7. Then on the next page, page 493, we are going to go through 27 odds. Actually, that's over on page 494. So we'll have, on this page, we'll have 9 through 25 odds. So again, you're just setting up your proportions, or in the beginning, it just says if the triangles are similar. If so, state the similarity in postulate or theorem. So
Miss
remember,
Jennifer,
uh-huh.
I already did the homework for 8-5.
Okay, great. Then you're
Oh.
ahead.
It was 7 to 27 odds.
Yeah. But on this page, it only goes to number 25. So we have to turn the page to get to 27. That's why I was just saying.
Oh, okay.
Yeah. So for this first section, we're determining angle, angle, side, 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 angle, side. And then again, same thing here. Draw the given triangles roughly to scale. So just, you know, they don't have to be perfect. Then name a postulate or theorem that can be used to prove. Okay, so again, we're looking at angle, angle, side, 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 angle, side for numbers 9 through 17. Now for 19 through 25, we are using our measurements and we are trying to find measures of angles and measures of sides. So you're going to set up your proportions and also your relationships of knowing measures of angles. So I can see automatically if I look right here and I say, hey, if this is a right angle right here and this is 45 degrees, I can add those two together, subtract from 180, find this angle here. Likewise, if this one's 53 degrees and this one right here, I know that if this side is a right angle, then that one has to be a right angle too. Okay, so now I know this one's 90, this one's 53, 180 minus that, find that one. Okay, so finding angle measurements and finding sides. And then turn over and we've got number 27 at the top of 494. Determine whether the triangles are similar. So notice I've got 2 triangles right here. So I'm trying to determine if they're similar and tell if they are, write a similarity statement. So if you start with ABC, ABC is similar to what, and then also solve for the variable. Okay. All righty. Let's go ahead and look at 8.6. Proportions in similar triangles. All right, so it says in this lesson, you will study 4 proportionality theorems. Similar triangles are used to prove each theorem. You are asked to prove the theorems in exercises 31 through 33 and 38. So in your notes, the first one says we are dealing with 4 theorems of proportionality, and I've got them numbered 1, 2, 3, and 4. So obviously the first one is going to be the triangle proportionality theorem. And it says if a line, and my first blank on my sheet will be parallel, if a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Okay, so those are your blanks, parallel and sides. Then it says to draw an example of this theorem and write the statement. So you are drawing this picture here and writing the if-then statement. So basically it says that if TU is parallel to QS, then RT over TQ equals RU over US. Okay, so if I have those 2 parallel lines, then I know that RT over TQ is equal to RU over US. And that is the triangle proportionality theorem. And then we have the converse of that just below it. And the converse of it says that if a line divides 2 sides of a triangle proportionally, then it is parallel to the third side. So that blank is parallel. If a line divides two sides of a triangle proportionally, then it is parallel. And again, you're going to draw your picture and your if-then statement. So this one basically says, if I have proportional sides, then my two lines are parallel. The other one said, if I have parallel lines, then I have proportional sides. So remember, converse is just the flip-flop. So that we've got, that's what we've got there. So now we're going to use these in example 1. So it says in the diagram, AB is parallel to ED, BD is 8, DC is 4, AE is 12. So what is the length of EC? Okay, so we just talked about how, and it tells me that my lines are parallel. So I can see here, because they've put my two little arrows, I know which my parallel sides are. So we said that if BD over DC is going to be equal to this over this. And again, it doesn't matter which one's the numerator, which one's the denominator. I just need to be consistent. So I could either have 8 over 4 is equal to 12 over X, or I could have 4 over X is equal to 8 over 12. Either way, when I cross multiply, same thing. So I'm going to have 8X is equal to 48. Divide by 8, divide by 8. And so X is going to be 6. So that means side EC will be 6. Any questions on that? Look at example 2, determining parallels. It says, given the diagram, determine whether MN is parallel to GH. So again, what I've got to do is I've got to set up my proportionality statements. So if these two are parallel, then I can have 21 over 56 is equal to 16 over 48. So I said 21 over 56, 16 over 48. So now I'm going to multiply, and 21 times 48 is 1008, and 56 times 16 is 896. Those are not equal to each other. Okay, so those are not equal. Same thing if I would have looked at the sides and said, hey, I've got, I could have flip-flopped that and done 56 over 21 equals 48 over 16. Again, either way, they are not proportional. So what they did is they said, okay, 56 over 21 reduces to 8/3. 48 over 16 reduces to 3 over 1. 8/3 is not equal to 3 over 1. So no matter which two sides you decided to compare, they are not going to be. And also remember that anytime I try to set things equal, if I set up a proportion, if when I cross multiply, if they are equal to each other, then it's going to be a true statement. But if they are not equal to each other, then in this situation, these are not parallel lines. Since my sides are not proportional, my lines are not parallel. All right, let's look at theorem 8.6. This is number 3 on your notes. And it says 3 parallel lines intersect 2 transversals. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So if you want to look at this one, we can kind of call this one the railroad track theorem. Because it looks like railroad tracks, okay? Remember, my parallel symbols are kind of railroad tracks. So I can call this my railroad track theorem. So it says that if R is parallel to S and S is parallel to T, and L and M intersect R, S, and T, then UW over WY is equal to VX over XZ. So basically, I've said if UW over WY is equal to VX over XZ. Okay, so I can compare these two over these two. Those are going to be parallel if I have parallel lines intersecting two lines. Okay. And then theorem 8.7, if a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So we can kind of think about this one as like a bow and arrow. Okay, but remember this right here. We just said that this is a ray that bisects an angle. So it's an angle bisector. We've talked about how an angle bisector, remember, it cuts these two. This would be my total angle measure of both of them together. And then I can see that they're going to be congruent to each other when they're cut in half. But basically what this is saying is that if CD is my bisector, oh no, my page disconnected. Okay, so what I'll do is we'll just go ahead and, well, let me try to get it hooked back up real quick. Okay, so basically it says if CD bisects angle ACB, then AD over DB, so this over this is congruent to CA over CB. Okay, so let me do those in different colors. We'll make those. Then I can see that this one over this one. Okay, so I'm taking my side that is the side that is intersected by the ray. So I have that side of my over here, AD over DB is equal to each of my sides, my other two sides. Okay. So when I have that bow and arrow looking symbol or the picture, and that's an angle bisector, this one over this one is equal to this one over this one. Okay. So that gives us our notes for that. So what we will do is, tomorrow we will pick up with 8.6. We will cover 8.6 and 8.7. So if you have not, I'll tell you what, I will make a place. Let me go ahead and disconnect this real quick. Stop share. Okay. So what I'm going to do is I'm going to go into our website. I'm going to set up a tab for test 7. So whenever you have test 7 corrections, if you have not already sent them to me, it'll give you a place to upload them. If you'd rather text them or email them to me, that is fine as well. It is totally up to you. Okay, so I know that I've gotten some corrections already. You do not need to re-upload them if you have already sent them to me. Okay, I just wanted you to have a place that if you did not want to text them or email them, if you'd rather upload them, I'll go ahead and put that in there right now for you to be able to upload test corrections for chapter 7. So that's what I want you to focus on. If you have not gotten those done, please try to get those done by tomorrow. That'll be your only homework for right now. tomorrow we will finish up 8-6. We will move on to 8-7. And then we're at the end of another chapter again. Okay, so that means the beginning, I guess next Wednesday, we'll do kind of a chapter review, go through, and then your next test will be sent home, I guess next Thursday. All right, so let's see, I'm gonna go ahead and put in assignment name is test 7. Any questions before we get ready and go?
When is the homework due?
Okay, so what my plan is, obviously, usually our pattern has been to check homework on Wednesdays. So whatever homework we've had from the previous Wednesday and Thursday, on Wednesday, we check it. You need to have it finished before we check it, okay? So there's a difference between when it needs to be finished and when it is due. It needs to be finished by next Wednesday when we go over homework, but it will not be due until we turn in the chapter 8 test. So hopefully, here's the plan. I guess this will be, because somebody was asking me about this at the beginning of class. I guess realistically, since we're online this week, if we get the test next Thursday, then it actually won't be turned in until we return to co-op after the winter break. So then we will be able to turn in all of chapter 8 homework, the chapter 8 test, and the chapter 8 notes. We'll be able just to turn that all in at one time when we return to the co-op. Okay, so actual due date, I think Easton, we were talking about that at the beginning of class. Did we lose Easton again? We've already lost him. So anyway, so go ahead, keep all your homework organized, keep it all together, and we'll just actually turn it all in when we return to the co-op.
And when is that date?
That date is, let's see, the 15th through the whatever is the week that we are out. So let me see what that actual date is. Calendar. So the 22nd, February 22nd is when all of our chapter 8 work will be turned in. Okay, so I'm going to go ahead and put in the computer though for the chapter 7 test. I'll put that in. So there is now a place for you to upload corrections if you want to upload them, but you can also feel free to text them or email them to me. So homework corrections, I already had a place in there. Check me out. I was already way ahead. Okay, so test corrections, and I'll see y'all tomorrow.
Bye, Miss
Y'all need
Jennifer.
anything, be sure to let me know. If not, I'll see y'all tomorrow. Look for that email that I sent that has the links
Yes,
with
ma'am.
both of them in it, and tomorrow the Thursday link. All right, bye
Thank you.
guys.
Bye. Thank
Thank
you.
you guys.